Hi guys, this is Mrs. Lyons. Today we're going to talk about covalent bonding. And covalent bonding, we haven't done a lot with. Covalent bonding is when we have two or more nonmetals. And it's when electrons are shared between the atoms. Okay. So electrons are shared between the atoms. For example, if we have Cl2, which is just chlorine gas. Okay, but we have two chlorine atoms. If we draw the Lewis structures for chlorine, remember each chlorine has 7 valence electrons, so we would draw our two chlorines like this. It doesn't work for one chlorine to give an electron to the other chlorine because they don't both end up happy. So in an effort to make both chlorine atoms stable, what's going to happen is they're going to share these two valence electrons. So we're going to draw this with the valence electrons in the middle between the two chlorines and then the other valence electrons around the outside. And if you look, now each chlorine has 8 valence electrons. So it's got a stable configuration, a stable form, the most stable form, like the noble gas. But the way to accomplish that is by these two electrons being shared. So this chlorine claims these 2 electrons, and so does this one. Okay, we can also draw this, we can represent a bond as a single dash line between the 2 atoms. Okay, so we could also draw this like this. And this bond, this line, represents 2 shared electrons. We also refer to these electrons that aren't shared as lone pair electrons. Okay, because they're alone on the atom. They're not shared electrons. So let's look at some of our rules for writing these covalent compounds. Okay, you can read through these rules. You can pause the slide and read through these. We're going to do an example using these rules on the next page. So you'll have these rules. The important thing I want to point out is down here, if you look, it tells us hydrogen and halogens. Remember, the halogens are fluorine, chlorine, bromine, and iodine. Hydrogen and halogens can only make one bond. They only bond once. Oxygen and anything in the same group as oxygen forms 2 bonds. Nitrogen and anything in the nitrogen group forms 3 bonds. And carbon can form 4 bonds. Let's look at an example of these steps of how to draw the Lewis structure. So step 1 says count up how many valence electrons are available. So we want to know how many available electrons are there. So we're going to do an example of CO2. So we want to look, carbon has how many valence electrons? It has 4. Oxygen has 6. We have 2 oxygens though, so we're going to have 4 electrons from carbon, 12 electrons from oxygen, for a total of 16 available electrons. Alright? Now, the thing that we know is when atoms are most stable, they want to have 8 electrons. So we want to know the number of octet electrons. What that means is if each carbon ended up having 8 electrons, and each oxygen ended up having 8 electrons, how many total electrons would that be? So we'd have 8 for carbon, 16 for oxygen. So that would be 24 electrons we would need to make this compound stable. Now, what we're going to do is we're going to figure out the number of bonding electrons. That means the number of electrons that are involved in bonds. This is equal to the octet electrons minus the valence electrons. So 24 minus 16 gives us 8 electrons that are going to be shared. Okay, so they're going to be involved in bonds. We can figure out the number of bonds by taking 8 divided by 2 because there's 2 electrons for each bond. That tells us that we are going to make 4 bonds in this CO2 or carbon dioxide molecule. All right? Now, how are we going to draw that? We're going to put carbon in the middle. Whichever element is listed first is typically our middle element, unless it's hydrogen, and then hydrogen can never be in the middle. Okay, so we're going to draw carbon, then we're going to draw our 2 oxygen, one on either side. Now this tells us we need 4 bonds. Well, if we put 1 bond here and 1 bond here, that's only 2 bonds between our carbon and oxygen. So what we're going to do is we're going to draw a second line between each carbon and each oxygen. That's called a double bond. It represents 4 electrons. So now we have 4 bonds. Now, how many electrons do we have left over? The number of non-bonding electrons is equal to the number of valence electrons from number 1, so that's in our case 16, minus the number of bonding electrons from number 3. In this case, our bonding electrons was 8. So that leaves 8 what we call lone pair electrons. And we're going to put those around the atoms that need to fulfill their octet rule. So if you look, carbon, if we count each bond as 2, carbon has 2, 4, 6, 8 electrons. So carbon is satisfied. Oxygen, however, is not. So if we draw 2 electrons around each oxygen, okay, we've used up 8 lone pair electrons. Now if you look, oxygen, if you count up how many electrons are around oxygen, we've got 1, 2, 4, 6, 8. If you look at how many electrons are around carbon, 2, 4, 6, 8, because each line represents 2 electrons. How many bonds around this oxygen? 2, 4, 6, 8. So everything has a full octet of electrons and everything is stable. Let's do another example. All right, we're going to draw the Lewis structure for NF3. All right, so the first thing we want to do is figure out how many valence electrons. So we have 1 nitrogen. Nitrogen has 5 valence electrons. We have 3 fluorines. Each fluorine has, each fluorine has 7 valence electrons, so 3 times 7 is 21 plus 5. We have 26 available electrons. How many valence electrons would it take to make each atom have 8? So if nitrogen had 8, each fluorine had 8. There's 3 fluorines. So that would be 8. 3 times 8 is 24. So there would be 32 valence electrons needed. Now, to figure out how many bonding electrons, we take that 32 minus 24. What does that give us? 6, 7, 8 electrons are involved. Oops, 32 minus 26. Sorry. So 32 minus 26 is 6 bonding electrons. So that is going to be equal to 6 divided by 2 is 3 bonds. Okay, because we want to take the number of bonding electrons, divide it by 2. That tells us we need 3 bonds. So now we're going to arrange our atoms. Nitrogen's first, so it's going to be in the middle. Then we're going to put the 3 fluorines around it. Okay, we need 3 bonds, so we're going to draw 1, 2, 3 bonds. All right, now, how many lone pair electrons do we have? Remember, what we're going to do is we're going to take our available electrons, 26, subtract our bonding electrons from it. That tells us we have 20 lone electrons. Well, we're going to put them around the atoms on the outside. So we put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now if you look, the reason that we did this way is fluorine now has 2, 4, 6, 8 valence electrons. This fluorine has 8 valence electrons. This fluorine has 8 valence electrons. And the nitrogen has 8 valence electrons. So this is our Lewis structure for NF3. Let's try H2O. Alright, so the first thing we do, we count available electrons. Okay, so hydrogen only has 1 electron available. We've got 2 hydrogens, so that's 2. Oxygen has 6 available electrons. That tells us we have 8 electrons available. How many do we need? Okay, now remember, hydrogen is the one exception to the rule. Hydrogen only needs 2 electrons. So we've got 2 times 2 is 4. Oxygen wants a full octet for 8. So that's 12 needed. So now we're going to take 12 minus 8 gives us 4 bonding electrons. Okay, now we're going to draw this. Remember I said hydrogen can never be in the middle. So even though it's listed first, oxygen is going to be our central atom. Then we're going to have 2 hydrogens, 1 on either side. We've got 4 bonding electrons. If we divide that by 2, it tells us we have 2 bonds. So we put a bond here, a bond here. All right. Now the last thing we have to figure out is how many lone pair electrons. So in this case, we take our available electrons, 8. We subtract our 4 bonding electrons. That means we have 4 lone electrons. We can't put them on the hydrogen. Remember, hydrogen only wants 2 electrons. So if the only place to put them is on the oxygen. And we put 1, 2, 3, 4 lone pairs of electrons. And if you look at this now, look at the way the electrons are arranged. Hydrogen has 2. This hydrogen has 2. Oxygen has 8. So every atom is in its most stable configuration. Let's do one more. SiCl4. Okay, step 1, available electrons. Silicon has 4. Chlorine has 7 valence electrons available. There are 4 chlorines. So we have 4 plus 28. So we have 32 electrons available for this molecule. How many do we need if every atom was to have a full valence? Silicon would want 8. Chlorine, all 4 chlorine would want 8. So that's 8 plus 4 times 8 is 32. So we would need 40 electrons. So we have 32 available. We need 40. So remember, we take 40 minus 32. That gives us our bonding electrons. And then if we divide that by 2, it tells us we have 4 bonds. So if we're going to draw our silicon in the middle, we're going to put a chlorine on each side. We need 4 bonds. 1, 2, 3, 4. How many lone electrons do we have? Let's see, we had 32 available minus our 8 bonding electrons. So 32 minus 8 is 24, right? That's 24 lone electrons. Let's see if we fill this in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And let's look. Chlorine has 8 electrons. Silicon has 8 electrons, or excuse me, each chlorine has 8 electrons. And then finally, silicon with 4 bonds has 8 valence electrons. So all of our atoms are in their most stable electron configurations. Let's do this one. This is the hardest one. HCN. Alright, remember H can't be the central atom, so carbon is going to be our central atom. Let's count up how many available electrons. Hydrogen has 1 valence electron. Carbon has 4. Nitrogen has 5. So that gives us a total of 10 available electrons. How many are needed? Hydrogen wants 2. Carbon wants 8. Nitrogen wants 8. So 8 plus 8, 16, 17, 18 needed. Alright, so we take 18 minus 10, tells us there are 8 bonding electrons. So let's see if we start drawing this, carbon in the middle, then nitrogen and hydrogen. We know hydrogen can only form 1 bond. Let's see, 8 bonding electrons. If we divide that by 2, 8 divided by 2, we want to make 4 bonds. So 1 to the hydrogen. Remember, nitrogen can make 3 bonds, carbon can make 4, so we can do 1, 2, 3. This is called a triple bond. There's 6 electrons in there. So now we've got 1, 2, 3, 4 bonds in our molecule. Do we have any leftover electrons? Let's see, there were 10 available, 8 involved in bonding. That leaves 2 lone electrons. Where do those lone electrons need to go? If you look, hydrogen has 2 electrons. It's completely stable. Carbon has 3 bonds here, 1 bond here, so it's stable. Notice nitrogen has 3 bonds, so only 6 electrons. So nitrogen needs that extra 2 electrons. Now, nitrogen has 8 electrons and its most stable electron configuration. So hopefully that gives you a little bit of an idea of how to draw Lewis structures for covalent compounds. We will practice this more in class, but this should give you an idea. Sorry the video is so long, but it takes a little bit I wanted to give you plenty of examples. I will see you soon. Have a great day.